Hello students, this is video number 4 for soil mechanics, and today we will study volumetric relationships. Right, this is the topic that we are going to study today. This is video number 4, soil mechanics and geotech engineering 1. So let's begin. See, volumetric relationships means we are trying to find some ratios of different volumes that we used in the three-phase diagram. First one is void ratio. You can also think of simply that some basic terms that we are learning. As we have to move ahead in soil mechanics, we must know some basic terms, right? Number one is void ratio. So let us go to three-phase diagram, right? Now in this figure, you know that this is air, this is water, these are solids, right? And you also know that this is volume of air, right? This is volume of water, and this is volume of solids, right? And these two taken together is volume of voids, right? So void ratio, which is represented as E, is equal to E. A void ratio is the ratio of volume of voids to the volume of solids. Volume of voids, that means this volume of voids to volume of solids. This is volume of solids, volume of solids. This is how void ratio is defined. Okay, so this is the first term that we have defined, void ratio, right? Let us go now to second term, that is porosity. So what is porosity? Porosity is the ratio of volume of voids to the total volume, right? So again in this figure you can see what is this? Volume of air, volume of water, volume of solids, volume of voids, right? And then again this is total volume, right? So how we define porosity? It is denoted by letter N, right? N is equal to volume of voids to the total volume. Now see, in case of void ratio, it was volume of voids to the volume of solids, but in case of porosity, it is volume of voids to total volume, right? And you can multiply it by 100 so that you can get it in percentage, right? Now tell me, is it possible that n value is more than 1? Is it ever possible? It is not possible, as volume of void can never be more than total volume. Is it ever possible that volume of void will be more than total volume? No, it is not possible. Hence n cannot exceed value of 1 or 100%, can never be greater than 1, right? or 100%, right? So this is porosity. Now, is it possible to find a relation between porosity and void ratio? N and E. Is it possible? Let us see. What is N? We have just learned that it is volume of voids to total volume, right? Okay. So what is 1 by N? Isn't it volume by volume of voids? Yes. So it can also be written that 1 by N is equal to total volume, can be written as volume of voids plus volume of solids divided by volume of voids. Now volume of voids divided by volume of voids is 1 plus volume of solids by volume of voids. That is equal to 1 plus. Now this is volume of solids by volume of voids. We know that void ratio is volume of void by volume of solids, right? So what is volume of solids divided by volume of voids? It is 1 upon E. So it is 1 upon E, right? So what we have found here, that 1 upon N is equal to 1 plus 1 upon E, or 1 upon N is equal to 1 plus E upon E, or N is equal to E upon 1 plus E. So this is the relation between porosity and void ratio. Also you can write E is equal to N upon 1 minus N. Hence if you know void ratio, you can know porosity, and if you know the porosity, you can know about the value of void ratio. This is the relation between void ratio and porosity. Let us now go to the next term. Third term is degree of saturation. Degree of saturation, right? Let us see what it is. It is the ratio of volume of water in the volume of to the volume of voids, right? Let me explain this. See, this is your figure, right? And you know it very well that this is air, water and solids. Now degree of saturation states that with respect to volume of voids, what is the amount of water, or what is the volume of water. So degree of saturation, or S, is defined as volume of water to the volume of voids. You can multiply it by 100 to get into percentage, right? Now it is very much possible that not even a single void is filled with water, that is, the soil is totally dry. Hence volume of water will be equal to 0, and we can say S is equal to 0. Also it is quite a bit possible that every single pore or every single void is filled with water and the soil is fully saturated. Then volume of void will be equal to volume of water, right? And in that case S is equal to 1 or 100%. So we know that the S varies from 0 to 100%, 0 to 100%, right? Or 0 to 1, right? Next term is air content. Air content. Let us see what it is. Air content is the ratio of volume of air to the volume of voids. So this is the this is air, water and solids. Here there is some volume of air, and this is defined as volume of void, right? So we define air content as AC is equal to volume of air to the volume of void. You can also multiply it by 100 to get the answer in percentage, right? So here also you can see that the soil, maybe it is possible that the soil is fully saturated and there is no air in the soil. In that case, air content will be 100%, and if the soil is completely dry, there is not a single drop of water in the soil, in that case volume of air will be equal to volume of voids, and hence E will be equal to 1, right? So it can be 0 to 1 or 0 to 100%, right? There is another term called percentage air voids, right? Percentage air voids. Now it is denoted by Na, and it is the ratio of volume of air to the total volume, as we have seen previously that air content is volume of air to the volume of voids. But if we take the ratio volume of air to the total volume and multiply it by 100, it will give us percentage air voids. That means with respect to the total volume of soil, what is the amount of air present in it, right? So we defined 5 terms, right? The terms like void ratio, porosity, degree of saturation, air content, and percentage air voids. Now there is a relationship between air content and percentage air voids, right? Let us see that relation between air content and percentage air voids. Let us see. Now we know that percentage air voids is nothing but volume of air by total volume, correct? And we can write it like this. Can we? Just tell me. Can we write, because volume of void and volume of void can be cut, and hence it is VA by capital V. So it's okay, right? Now the same thing can be written as we know, VA upon VV is nothing but AC, air content, right? Also VB upon V, that is volume of voids divided by total volume. What is this? Volume volume of voids divided by total volume is porosity, right? So volume of void by total volume, porosity. So what we got, Na is equal to, that is percentage air voids is equal to air content into porosity. So this is the relation between the two, right? One more term is there, which is water content. Let us see what is this. Water content. So let us go to the 3-phase diagram once again. Right, and we know that this is air, this is water, this is solids. And we also know that this is mass of air, that is negligible. This is mass of water, and this is mass of solids. So what is water content? Water content, which is denoted by W, is equal to mass of water divided by mass of solids. Mass of water divided by mass of solids, right? Now do you know that if we simply multiply mass of solids with G, we will get what? Weight of solids. If we multiply mass of water simply with G, we will get weight of solid. So water content can also be written as weight of water by weight of solids, right? And if you want to get it in percentage, simply multiply by 100. So I think so these 6 terms must be clear to you all. That's it for the class. Thank you very much.